So now let us solve some questions on derivative of trigonometric functions. First example is that we have to differentiate y is equal to x cos x. As you can see, there are two functions in the product. One is algebraic, which is x, and second is trigonometric cos x. So obviously we have to apply product rule. So just let us apply quickly product rule that dy by dx is equal to taking the first function derivative and taking second function as constant, right? So let us differentiate x first and writing cos x as it is, plus, because derivative of x is 1, okay, so this is 1 into cos x basically, and then we will take x as constant and differentiate cos x, which is minus sin x. Okay, so derivative of dy by dx of this y equal to x cos x is cos x minus x sin x. Okay, first part, simple. Second says we have to find the gradient of the curve at the point x equal to pi. As we know, the derivative function gives you the gradient at any point. So at x equal to pi, we have to put x equal to pi in the derivative function. So dy by dx at x equal to pi will be cos pi minus pi times sin pi. Okay, so cos pi value is minus 1 and sin pi is 0, right? So pi into 0 is 0. So gradient at x equal to pi is minus 1. Okay, third part is find out the equation of tangent to the curve y equal to x cos x at the point where x is equal to pi. So at x equal to pi, we know the gradient of the tangent is minus 1, and equation of any straight line is given by y minus y1, means if you know the point and the slope, you can find out the equation of any straight line. We have been given the point, only the x coordinate is given though, but we can find out the y coordinate also, means we can find out the point where the tangent is required. So y minus y1 is equal to m times x minus x1 is the equation of any straight line at a point x1 y1 whose gradient is m. So first of all, we need to find out the y coordinate at x equal to pi. Okay, although please do not get confused, because in differentiation these types of questions where we have a function, then we have the derivative function, then we have tangents, then we have stationary points, right? So there are so many y's involved. Okay, so just keep the sequence in order, that where we have to put the value of x equal to pi, whether in the differentiation function, derivative function, or in the original function. So points are always determined. Points means coordinates are always determined by putting the points in the function, original function, not in any derivative of or second derivative functions. Derivative and second derivative function, they have different meanings. They give you some points though, but these points are not the points which lie on the curve, not necessary. Okay, if you are finding the coordinates of the point, means it is asking about the points which are lying on the curve. Okay, so putting the x coordinate in the function y, you will get the y coordinate. So our function is x cos x. So at x equal to pi, y coordinate is pi cos pi. Okay, cos pi is minus 1. You need to remember this value. No need to just use your calculator on and on. Okay, some values you need to remember. So this is minus pi, just to make calculations quickly. So y coordinate now is minus pi. You have a slope which is minus 1, slope of the tangent. Easily you can find out the equation of tangent. Here it is y minus of y1, which is minus pi, is equal to minus 1 slope x minus x coordinate, which is pi. So you have y plus pi is equal to minus x, again plus pi. These pi's get cancelled. Equation of tangent is y is equal to minus x. Okay, this is your third. You can pause the video and watch again if there is any doubt in this, because I have to just repeat what I have done. Okay, this is the plus point in making the videos, because in the live classes I need to repeat this again and again, right? But in these online lectures you can pause and again watch what I have said. So fourth part is we have to find out the equation of normal again at point x equal to pi. So y coordinate at x equal to pi will remain same, which is minus pi. So you have a point which is pi and minus pi. Only difference is that slope of the normal in this case will be plus 1, because you will use the formula of two perpendicular lines. The relation between the slope is m1 into m2 is minus 1. So if you are taking m1 as slope of the tangent at x equal to pi, which is minus 1, the slope of the normal m2 will be equal to plus 1. Okay, because m1 is minus 1, so m2 is plus 1. So now here you have the slope, you have the point. Easily again you can find out the equation of normal, which is y minus y1. So y plus pi is equal to, this time slope is plus 1, x minus pi. So y is equal to x minus 2 pi is your equation of the normal. Okay, very simple. Next question is, the equation of a curve is y equal to x plus 2 cos x. Find the x coordinate of the stationary points of the curve between 0 to 2 pi. Some angles will be given to you, or you have to find out some angles, and then we have to determine the nature of these stationary points, right? So let us analyze the course of action that we need to follow in this. It is asking about the stationary point. That means we need to first differentiate the given function and then equate to 0. You will get some values of x, and then we have to again differentiate this to find out the nature, means which point will be maxima and which point will be minima. Okay, that means the double derivative also we need to find out. This is the plan, let us follow. So first step is finding out the gradient, which is 1 minus 2 sin x. X derivative is 1, cos x derivative is minus sin x, and 2 will remain constant. Okay, so 1 minus 2 sin x. Now we put this equal to 0 to find out the stationary point. That means value of sin x is half. That means your stationary point is at, as x is, sin x is half, means positive. Sin x remains positive in first quadrant and in second quadrant. Principal value of the angle is 30 degrees or pi by 6, right? So in the first quadrant, value corresponding to first quadrant is pi by 6, and angle corresponding to the second quadrant is pi minus pi by 6. So you have two stationary points, one is pi by 6 and second is 5 pi by 6. Okay, so these are the stationary points between 0 to 2 pi, where the gradient of the tangent is 0. This is the meaning. Okay, now we have to find out the nature of these stationary points. As you know that nature of each stationary point is determined by second derivative. You put the each stationary point in the second derivative. If your second derivative is positive, it is minima. Please do not get confused, because it comes to our mind that negative value corresponds to minima, right? Which is smaller, so smaller means negative. No, it is just the opposite. If the value of the second derivative at any point is negative, it is maxima. If it is positive, it is minima. Okay, so second derivative is, one derivative is 0, minus 2 will remain as minus 2, and sin x derivative is cos x, so it is minus 2 cos x. Your second derivative is minus 2 cos x. Now at this, let us put x equal to pi by 6, which is 30 degrees, to find out the nature, to find out the sign of this. Now cos x means cos pi by 6. It is in the first quadrant between 0 to 90 degree. Cos is always positive, right? 0 to 90 degree, each and every trigonometric function remains positive. So cos x is positive, multiplied by negative number, so this is less than 0. At x equal to pi by 6, second derivative is coming out to be negative. So we have that x is equal to pi by 6 is a point of local maxima. Okay, now you have two stationary points. If you know the nature at one point, second point is obviously the other one, because maxima and minima, they come alternately, right? You don't have any curve which is having two, you know, side by side maxima or minima, right? Two continuous maxima won't be there, two continuous minima won't be there. They always come alternately. One is maxima, then other will be minima. So at x equal to pi by 6, it is maxima. So x equal to 5 pi by 6 is 5 pi by 6 is a point of local minimum. Okay. Easy weasy. Next is, let us do last question in this. The curve y is equal to e raised to power x upon cos x. First question we did about product rule. This question is about quotient rule, right? Because quotient rule and product rule, they come in combination with all these different types of functions, right? I think we have done these product and quotient rule in differentiating exponential and logarithmic functions. So here some more combinations of the functions will be there, in which you have to apply product and quotient rule. As you can see here, now the two functions are not algebraic. One is trigonometric, one is exponential. So quotient rule we will apply, and it is asking about the, it says that it has only one stationary point between minus pi by 2 to plus pi by 2. Minus pi by 2 plus pi by 2 means it is saying that in the first and fourth quadrant, first thing is this, and angle we have to measure, one is anti-clockwise, another is clockwise, right? Positive values are for anti-clockwise, negative is for clockwise. Okay, so let us differentiate this product quotient rule. Denominator square, this is cos square x, then writing cos x as it is our guest in the numerator. Differentiate e raised to power x, which is e raised to power x, apply a minus sign, write numerator function as it is, and differentiate cos x, whose derivative is minus sin x. So this minus and minus will become plus, you will get e raised to power x sin x. Okay, this is your derivative function. Now to find out the stationary point, you need to put this equal to 0. As denominator cannot be 0, you will have e raised to power x cos x plus sin x is equal to 0, means only numerator is 0. Now within this numerator, there are two possibilities. Either e raised to power x is 0 or cos x plus sin x is 0. Now e raised to power x is an exponential function. If x is positive, it is always increasing. If you remember the graph of e raised to power x, it is like this. Okay, so this exponential function is getting 0 at x equal to minus infinity. Okay, here we have at x is between minus pi by 2 and plus pi by 2, meaning that e raised to power x cannot be 0 within its domain, as infinity points are never in the domain, right? Though we write the domain, but the exact point we do not know, right? So we say normally that exponential function, they can never become 0. So now you're left with only one option, that this bracket has to be equal to 0, right? That's why it is saying that it has only one stationary point. Now put cos x plus sin x equal to 0, you will get cos x is equal to minus sin x. That means I will get tan x as minus 1. Okay. Now tan remain negative in two quadrants. One is second, one is fourth. Initially, but question is saying that domain is between first quadrant and second quadrant and fourth quadrant. So this second quadrant option is ruled out, where tan x is negative, right? So that's why it is saying that it has only one stationary point. Okay, and that is lying in the fourth quadrant. Fourth quadrant angle are given, either we move clockwise or anti-clockwise. Here we have to move clockwise because it is minus pi by 2. Okay, so tan x remains plus 1 at principal value of 45 degrees, pi by 4, right? But we have to measure this angle clockwise, means negative. So x is minus pi by 4. Okay, this is your x coordinate of the stationary point. Okay, Thank you. This is for trigonometric function, I think. I will come up with next video with some more topic in differentiation. Thank you. Take care.